Okay, welcome everybody to the Project Week AWS Nvidia MONAI Label workshop and tutorial. It's really exciting. I'm Steve Pieper, and I've been doing Project Week for a long time with Tina Kapoor and Simone Druin, who are here. And we're very excited to dig into the content. So without more introduction, I'm going to pass it over to Michael from Nvidia, Michael Zephyr, who will tell you a little bit about the MONAI project, and we'll take it from there.
Hey everyone, my name is Michael Zephyr, and I work at Nvidia as a developer evangelist and technical marketing engineer. And one of my main focuses is MONAI. So I'm one of the leads on the MONAI Adoption and Outreach Working Group. So I'm happy to be here and help out. I'm going to be helping moderate the session for today. And so the agenda for today will be that Steve gave a welcome to everyone. Qing's going to go a little bit over the AWS infrastructure piece of what we're going to be doing as far as the backbone infrastructure for today and walk you through those steps. I'm going to go a little bit over MONAI. If you don't know what MONAI is, I'll talk about MONAI as a project. What does it mean? What's part of MONAI? And then I'm going to hand it off to Andres to go a little bit more over MONAI Label specifically. And he's going to present a little bit about MONAI Label, a little bit more in depth than what I'm doing. And he's going to give you a hands-on piece as well. And last, I'm going to hand it over to Rudolf for a use case study on chest segmentation. And so we'll get started by handing it over to Qing. Go ahead and take it away, Qing. Introduce yourself and tell us a little bit more about the infrastructure that we're going to be using today.
Sure, absolutely. Thank you, Michael. I'm just going to share my screen.
Thanks, Steve. I noticed when we were going through, when I signed up for the Discord, and I didn't see a specific channel. I wanted to at least mention in case people have questions as Qing gets kind of started. Where should people comment in the or discuss things in the Slicer Discord?
Question. So far, we've been just using Lobby 1 for some of the meetings that we've had. So
okay,
unless we have problems with that, why don't we stick with that for now?
Okay, cool.
All right. Can you guys see my screen?
Yes. Yep.
Okay, great. Good morning, good afternoon, good evening, everyone. My name is Qing Liu. I'm a solutions architect with AWS. Today, I'm just going to give a quick overview of the infrastructure we have set up to support this workshop. So for the agenda, I'm going to go through the architecture and also talk about the core AWS services that we are using for this workshop. And then I will go through how we can log in and get access to the workshop content, such as 3D Slicer and MONAI Label server. So this workshop content is actually publicly available. We will have a link to share at the end of the presentation. So this is the architecture for the workshop. The workshop is designed to support two workflows for two personas. On the left-hand side, we have radiologists, and they will be able to use 3D Slicer that is deployed in AWS. And 3D Slicer is then connect to a MONAI Label server that is also deployed and running in AWS. And this will help the radiologist to do image annotation work. On the other side, we have data scientists. And for their workflow, they are going to access the annotation data that are created by radiologists and use machine learning to train their model. And this is enabled by using a shared disk, which we call AWS EFS. So there are a lot of AWS terminologies here shown on this diagram. So what I'm going to do next is to go through some of the core components of this architecture. So we are familiar with what technologies are being used here. So first, let's focus on the MONAI Label server. So the server is deployed in an Amazon EC2 instance. So what is an EC2 instance, right? So for people who made who may be newer to cloud computing or AWS, EC2 stands for Elastic Compute Cloud. So you can think of them as virtual servers hosted in the cloud. And in AWS, we have data centers across the globe where we call regions. So in each region, we have multiple availability zones, and availability zone is made up of one or more data centers. So in each of these data centers, we have physical servers, and with the help of hypervisor, we're able to partition resources from the host server into multiple guest systems, which we call them EC2 instances. So as you might imagine, depends on the workload, there's different resource demand. Some of the workloads are more CPU intensive, some of them are more memory demanding. And for our workshop use case, we need to have access to GPU instances. So that's why at AWS, we have a wide range of EC2 instance types for users to choose from. And the number of instance types has grown significantly over time. So by end of 2021, we have more than 400 different instance types to support different types of workload. So when we look at instance type, it follows a specific naming convention. So for example, our workshop MONAI Label server is going to be deployed on G5 2 X large instance. So what does this mean? Right. So if you look at the naming convention, it's made up of two parts. The first part before the dot is the family. So that's the instance family. The family usually starts with a letter, which indicates the category of the instance. So as I mentioned before, we have instance types that's designed for different types of workload. So for example, some of them are compute optimized, some of them are memory optimized, some of them are accelerated. So each of them has a specific letter assigned to them. So that's the instance family. And then followed by the letter, that's the generation. So as we are innovating with the hardware in our data center, we come up with new instance generations over time. So it starts from 1 and goes to, I think right now it's most of the instance types are either generation 5 or generation 6. So the bigger the number, the more recent the generation is. And if the instance has additional capabilities such as additional storage or using the latest Graviton 2 processor from Amazon data centers, they would have additional letters after the generation. And for each instance family, we also have a range of sizes for users to choose from. So starting from small, medium, large to 2x large, 8x large, all the way sometimes to like 64 or 128. So using G5 instance as example, so that the G5 instance we're using for the MONAI Label server falls into the GPU instance category. And under this category, we have two different families, P instance family and G instance family. And each of them is divided into multiple instance family types, and each one has a different Nvidia graphics card associated with them. So for G5, we're using A10G Nvidia graphics card with a GPU memory of 24 gigabyte. So as you probably seen in the previous slide, within a family, we also have multiple instance sizes. So from G5 X large all the way to G5 48 X large, they have different CPU and system memory configurations. And from X large to 16 X large, they use single GPU. But if you would like to use multiple GPU, in one instance, we have 12x large, 24x large, and 48x large for you to choose from, where each one of them has either 4 or 8 GPUs for you to use. So once we pick our instance type, what we have configured for the workshop is that we create a template, which is a template that we're using to deploy multiple EC2 instances to run MONAI Label server. Of course, these instances, by default, they don't have MONAI Label server installed. So what we are able to do is by creating that template and then have a server setup script configured. So it's going to run through a number of custom scripts that will enable us to install MONAI Label server, install the required drivers required by the MONAI Label server, as well as using the MONAI Label app to download datasets and applications required to run the MONAI Label server. So in the end, we do both of these steps and then set up a system service that's so that the MONAI Label server is automatically running when we deploy it. So that's how we set up the MONAI Label server. So once we have the MONAI Label server running in an EC2 instance, the next thing we are setting up is enable our users to access 3D Slicer. So to do that, we use Amazon AppStream. So Amazon AppStream is a managed AWS service to deliver the application experience to the user. So in this case, we are using 3D Slicer desktop application, but we deploy that in AppStream, which will allow our users to just use their browser to connect to the AppStream instance that's dedicated to that user and start using the 3D Slicer in the browser. So you can think of it as a remote desktop, but everything happens within a browser. The AppStream instance is a non-persistent desktop environment. What this means is that each user will get a brand new pre-built instance that has 3D Slicer installed. But at the end of the user session, the instance will be destroyed and not going to be reused by other users. And AppStream is able to scale up based on user demands. So for this workshop, we were able to scale up AppStream to support all of our users. And there are multiple ways to do this. AppStream can react to the number of sessions that's currently in flight and automatically scale up to meet the user demand. And also you only pay for what you use. For in our case, the AppStream the cost of AppStream is going to be based on number of sessions and the duration of the sessions. In an IT environment, AppStream can also integrate with existing identity providers, as well as Active Directory to streamline the user login process. But for our workshop, we're going to provision AppStream user account for each participant. And when they log in, they will get a dedicated AppStream instance to use. So AppStream service is also available globally. For this workshop, we have set up AppStream instances running in North Virginia region, as well as Ireland region to support users from different locations. And of course, we noticed that we have a number of users potentially could log in from Asia Pacific region. And because of the distance and latency between these users and the data center, the performance might not be very optimal. So please contact us if you are experiencing delays when connecting to AppStream and using the AppStream instance. We can either switch you to a different region, or we could consider doing another workshop that's designed specifically for Asia Pacific regions. As EC2 instance, we also offer a wide range of upstream instance types for different workloads. We have standard upstream instances, compute memory instances, and for our case, since 3D Slicer works well with a graphics card, we are using the upstream graphics instances to deploy 3D Slicer. So in our case, for this workshop, we have chosen to use graphics G4DN instance type. So this instance comes with a Nvidia T4 GPU with 16 GB GPU memory. So that's the instance we're going to use to run 3D Slicer in this workshop. And last but not the least, we have SageMaker to support the data scientist workflow. So this will not be focused for this workshop, but I still like to talk about the data scientist workflow to use SageMaker to train the machine learning models by using the annotation data provided by radiologists. So in AWS, we provide a lot of AWS AI ML services to our users, and we generally classify our AI ML services into 3 categories. At the top, we have AI services. So these are the AWS managed AI services that are designed for specific workloads. So these services, you don't need to train them. So they are already trained, and you interact with them by calling the AWS APIs. So for example, we have AWS services that are able to detect medical terminology. It's called Comprehend Medical. So you feed in free text data, and it's able to return you the ICD-10 CM codes, SNOMED code, and ArcStorm codes based on the free text data. So you interact directly with these services by calling the API. At the bottom of this 3 layer is the frameworks and the infrastructure. So this layer of AWS services are designed specifically for expert practitioners. So they will use the frameworks and the infrastructure we provide to build AI ML workflows. And in the middle, we have SageMaker. So this is included in the workshop content, but it's not going to. We are not going to be focusing on this service today. So this the SageMaker allows us to have an easy way to train machine learning models. So as an example, you can see here we have a screenshot on the right. Users can use SageMaker to launch Jupyter notebooks and as well as Jupyter Lab environments using SageMaker. So SageMaker also provides a complete experiment management, data preparation, and pipeline automation for the data scientists to do their work. So if you are interested to learn more about SageMaker, please ping us. We are happy to have a follow-up session on SageMaker, or you can also go to the workshop content website by scanning this QR code or going to that tiny URL, and you are able to set up the complete workshop solution in your own AWS account. So we estimated that the total cost to run this workshop in your AWS account should be less than $50. We are also happy to grant credits to cover that cost. So also please reach out to us if you like to try this out in your own AWS environment, and we're happy to issue credits to cover that cost. We have a number of AWS solutions architects here to support this workshop. Besides myself, we have Gun, JP, and Cass. So they will be monitoring the chat to answer any technical problems or issues that you might encounter during this workshop. All right, so Now let's talk about access. So as we are speaking, we are spinning up AppStream instances and EC2 instances that are hosting the MONAI Label server in the background. So once I get off the screen share, I'm going to start provisioning user accounts. So this is based on the registration list that we have collected in the last few weeks. Once the user account is provisioned, you will get an email like this that is shown on the screen. So what you need to do is click on the link, login link provided in the email. The email also contains a temporary password for you to use when you log in. So let me do a quick demo of how this works. All right, so this is the AppStream login page. When you click on the login link from the email, what you need to do is use the email included in the invitation and also the temporary password provided in that email. For the first time login users, you would need to provide a new password. Once you log in, you would see there are two applications available for you to use. The first is 3D Slicer, so you can click on 3D Slicer to launch 3D Slicer in your browser. So basically, this is a remote desktop into the AppStream instance that we have pre-built for each user. So in this instance, we have 3D Slicer already installed and the required extensions installed, such as the MONAI Label server extension, as well as the long CT extension for you to do this workshop. As you can see, the 3D Slicer is launching in the browser. So once 3D Slicer is launched, you can click on the MONAI Label extension icon at the top. Sometimes the browser will ask you to give it permission to share the clipboard with the remote desktop. You just click allow, so you can copy content from your local computer and paste that into the AppStream instance. Okay, so when you click on the MONAI Label server, you will see here it's got a input field for MONAI Label server IP address. So for each one of you, you will get a dedicated EC2 instance that's hosting the MONAI Label server. So how to get to that IP address and port number. So this is where you use the second application available in your AppStream instance, which is called Connect to MONAI Label server. So click on that. It's going to say, it's going to tell you the MONAI Label server that has been assigned to you, which is this URL with the IP address and port number. So this is a private IP address. It's only accessible within this AppStream instance. So what you need to do is highlight this and right-click, so that copies this piece of string into your clipboard, and you right-click and paste it here, right? And you click a refresh button here to connect. You can use the second button from the top. This gives you a way to navigate to a different window that's already open. So coming back to the command line, you also have the option to connect to the MONAI Label server. So if you type yes, it's going to SSH you into the MONAI Label server that's dedicated to you. So there are a couple of commands to help you get started. For example, if you would like to watch the MONAI Label server log, you can highlight this, right-click to copy, and right-click again to paste this. So if you enter this command, you can see the log from the MONAI Label server. So it's good to have this running in the background, so you can come back to use 3D slicer and do annotation. But if you want to check what is the server doing by looking at the log, you can switch to the command line window to take a look at the log. All right, cool. With that, I will hand over to Andres to walk through the 3D slicer with MONAI Label server workflow.
Thanks,
yeah,
Qing.
Michael, yeah. Do you want
Yeah.
to?
Yeah, I can go ahead and take over for now. So thanks, Qing, for that. One thing I'm going to do really quickly is I'm going to share my screen and show you for those who haven't used Discord before, if you're in Discord. So let me go ahead and share that screen. You should see my Discord screen here. If you have any questions, whether it was on what Qing just presented as you kind of get the email and set up, and you have any issues, go to your Discord. On the very top, you'll see these hashtag channels, lobby-1. That's where we're getting all of the questions in. They should be monitoring the chat for all there because there's about 3 or 4 different solution architects who are helping out on the AWS side. I'll be in there. Andres will be in there. And get involved, get engaged with the community. There is also the Lobby 1 voice channel. You don't have to necessarily join that. I do see some people in there. So if you get stuck in there, there is a disconnect sort of icon at the bottom left of your screen near your username here at the bottom left. So if you click that, it'll remove you from the voice channel. And then if you just want to ask a question, go ahead and feel free to join that lobby. And you'll see actually what I'm seeing here right in the middle of my Discord screen, where you can see Steve and a few others have already been commenting in that chat. I'll also monitor Zoom chat as well, and I have an aggregate doc where I'll collect all the Q&A. I'll stop the presenters as they're going along when it makes sense and ask them any other questions that you guys have, if it makes sense to bring it up on the actual, to the presenter itself. So I'm going to get started with the intro to MONAI for those who don't know what MONAI is, and then I'll hand it off to Andres for you guys to get started. So MONAI stands for the Medical Open Network for AI. And for the agenda today, you've already seen 2 of the speakers. So Steve gave us a welcome introduction. Qing talked about the AWS infrastructure, and I'm going to talk a little bit about MONAI as a whole. And then we're going to hand it off to Andres for MONAI Label and Rudolf for the chest segmentation use case. So MONAI was created back in 2019 as part of the around MONAI timeframe. And the idea was to get together a lot of the thought leaders in AI medical imaging, put together an advisory board, put together working groups to kind of help drive and guide what a project like what MONAI now is, which includes a lot of things around medical imaging and making sure that we bring in people who are relevant and thought leaders in the industry to make sure we're getting the best and brightest ideas within a framework, and a framework that has a few different key ideologies behind it. And so on the right-hand side, you see some of our advisory board. If you go to our monai.io website, you can click on them. It'll link to their pages if you want to know a little bit more about any of them. And on the left-hand side, you see our MONAI working groups. And so you'll see working groups ranging from things like imaging IO, reproducibility, federated learning, pathology, or deploy. So for MONAI, I wanted to give you a little bit of an idea of how decisions are made. So generally, decisions are made by a proposal that's created, and that could be for a GitHub discussion, a shared document, and depending on the scope of the idea, we kind of have 2 different paths. It either goes to the MONAI advisory board, which you just saw, and it gets approved there. And again, hoping that those thought leaders give us guidance to what makes sense to integrate into MONAI. And then those things kind of go through to the working groups and teams and leads and other people within the community if they're approved. Or for smaller ideas, they go directly to the working groups. And that could mean a document that talks about it, a GitHub repo that you want integrated into one of the existing MONAI repos, a GitHub issue, a pull request, or a release coming out of one of the repos on GitHub as well. So you can get involved in MONAI in a few different ways. Our working groups are free to attend. You can join any of them. If you have any issues finding one that you're interested in, feel free to reach out to me directly, Michael Zephyr. You can join our Slack channel. You can email me at mzephyr@nvidia.com, or just message me and ping me in Discord. If you want to get involved just by going to go look at our GitHub repo, you can go there, check out the issues, check out the different repos, check out there's contribution guidelines, how you should contribute, how you go about that whole process. So I encourage you to go through and look at the different repos there and figure out where you might want to contribute back to MONAI if you're really excited about it at the end of the day. But what is MONAI? And I talked about MONAI, the advisory board, the working groups, and the GitHub, but I didn't really tell you what is MONAI. And so MONAI has grown quite a bit since its inception. We now have a few different projects. And the idea, or the way that we sort of think about it, is we have this sort of flow going from data sets all the way through deployment. And we want to try to tackle what does that look like in a medical imaging sense, which is a little bit different than a normal AI pipeline. And so typically that starts with data sets. And we have our open data sets initiative happening, where we have data sets hosted on the AWS Open Data Repository. We're working on other things like model bundles and model zoos and other open data sets and integration with things like TCIA and other places where you can get data very easily into MONAI for tutorial workflows or for your own workflows. And the next one we go to labeling. And I'm not going to talk much about labeling, but the general idea here is that it helps you annotate and get your data set ready to go for training. And in the middle of that training, you're going to actually train a model itself. And Andres will talk a lot more about what labeling really means and how MONAI Label works in the flow. And then we have dedicated training. So maybe you have annotated data. We're going to go over to MONAI Core. This is where we have a lot of healthcare specific domain optimized capabilities. So those are networks, transforms, workflows, all of those good things that are in here. And it's actually used throughout all of the different MONAI pieces. MONAI Core is sort of that flagship framework that's used throughout everything. And then we move over to deployment. So deployment contains a few different pieces. There's app development for taking your model and creating a sort of nice reproducible application. And then there's the next step in deployment, which is how do you get this running up on a server? Maybe you have a Kubernetes instance or whatever that deployment infrastructure for you, whatever that means, and how can we help you with that process? I will mention the versions here are a little out of date. We actually have MONAI Label version 0.4, MONAI Core 0.9, and MONAI Deploy App SDK 0.3 right now. And we're going to have another release for MONAI Deploy App SDK coming up soon. To give you a slightly different view of it, so here's sort of the stack going from the bottom to the top and left to right. So from the bottom to the top, you're talking about sort of different systems and then going all the way up to MONAI applications as a whole. What does it mean for MONAI as sort of these more abstract or bigger things that kind of encompass all of MONAI? And so we start off with systems. So whether that means a cloud CSP, like you guys are going to be using AWS today, or your own system, getting that onto that system, and whether that's Ubuntu, Windows, or Mac, and then integrating with things like PyTorch, NumPy, CUDA, or Docker, or things like Kubernetes as well. And as you move up, MONAI core components kind of span all the different pieces from label, train, and deployment, because those include your transforms, your writers, metrics, all of the good things that you would normally think of needing in an AI pipeline, and a lot of medical specific pieces there as well. And then you move up and you have that workflow that I just talked about. So you have labeling to training to deployment. And last, the very top layer is sort of our MONAI apps, or sort of our MONAI high level things that you can integrate with. So what do things look like in a clinical workflow spec? And what do MONAI applications look like? Or our tutorials. We have a great tutorials repo. I encourage you to go over there and see what they're like. They're usually available to run really easily directly from the tutorial. You can clone it, you can run it on your own machine, whatever works for you. And then we have things like pre-trained models, manifest, label application, a lot of other good things that kind of are higher level abstractions over our base frameworks. So the overall design goal for MONAI is things that I've already talked about, but just to kind of go over them again: customizable, composable, domain specialized, GPU optimized, reproducible, and high quality. And that includes things like our tutorials that I mentioned just a second ago. We have a lot of tutorials there. Whenever we put out new architectures, new features, we try to have a tutorial that allows you to go through it and utilize it so you can get it into your workflow and see how it actually works. Reproducibility, composability, and customizability are all really important things because we want it to be easy for you to get started. Use as much or as little as MONAI as you like, and make it so that there's a good place to go back and have it in your research, in the projects you're using, and have a nice reproducible way to integrate it into your workflow, and hopefully for the community to adopt and contribute back to. So there is this one place that there is sort of a source of truth for everything where you can come back to. And things like GPU optimized, Qing talked about the different instances that they're using or that they have available, things like multi-GPU, using CUDA acceleration, and a lot of other good GPU optimized processes. And last, I want to talk a little bit about the adoption of MONAI. I mentioned it's been around since about late 2019. As of a few days ago, we had around 450,000 downloads for Project-MONAI overall. We're getting about 50,000 a month or so right now. And then we see some other numbers for Label and the MONAI Deploy App SDK. Those numbers are a little lower because it only came out last year. But we're getting a lot of traction there. We're getting a lot of people integrated into the MONAI Label ecosystem and a lot of just general contributions. So over 105 individuals, I think that's up closer to 150 now, over 30 institutions, and partners like King's College London, Stanford, Mayo Clinic, the NIH, the NHS, ACR, MGB, UCSF, and a lot of other companies and research institutions utilizing MONAI in their stack or integrating it into their workflows. So I'm going to hand it over to Andres. Andres, feel free to take over, introduce yourself, and get us started a little bit more about learning about MONAI Label.
Sure. Thank you, Michael. I'm going to share the screen right now.
Yeah.
You guys see my screen?
Yeah.
Excellent. Okay. Thank you, Michael. Thank you for the nice introduction. Okay, so hello everyone. I'm Andres Diaz-Pinto. I'm also part of Nvidia. I'm a technical marketing engineer, and I hope we learn a lot from this workshop. So before I start talking about MONAI Label, I'd like to highlight that this project, so the MONAI Label project, is a joint effort, is part of a collaboration between Nvidia and the London AI Center, King's College London and the London AI Center. The agenda that I'm going to follow for this workshop, for the MONAI Label part, is briefly talk about what is MONAI Label, the main highlights, the new features that we have, and then I'm going to discuss briefly why bothering about MONAI Label, why we should use MONAI Label, and the main, say, personas that we are aiming to, and all the things that MONAI Label allows us to do. Then I'm going to briefly show you how you can create a MONAI Label app, or how you can modify the MONAI Label apps that are available in the GitHub repository or the package. And then I'll briefly talk about what is the Scribbles algorithm and the active learning strategies that are available in MONAI Label. And then the last bit will be the hands-on session and the frequently asked questions. I prepared a bunch of questions that I usually got from the users, and that's the bit that I'm going to follow. So briefly, what is MONAI Label? Essentially, is a platform. It's an open source platform that facilitates annotation of medical images. So we started also with the pathology images. So we have both. The idea is to facilitate both the annotation of both type of images, 3D medical images and histopathological images. The good thing about MONAI Label is that it allows users to create annotated data sets and also build AI annotation models that can be used for clinical evaluation, right? So this means you can perform inference, you can train or update a deep learning model, right? And it's one of the platforms that includes active learning strategies to improve the model performance, right? Everything is written in Python. With a simple pip install MONAI Label, you should be able to start working with the platform. So that's the bit. So we also support 2 viewers for the radiology application, so 3D slicer, which is the one that we're going to use for this workshop. But we also have OHIF viewer for the radiology applications, and for the pathology applications, we have QPath and the digital slide archive, right? This project started in February 2021, and since then we have been on continuous development, continuous changing and improving the platform. So briefly, this is the structure of MONAI Label. Essentially, it's a server client system. We offer an API to communicate with the server. You can consume the APIs from wherever you want, right? So those APIs can consume from a user interface that we show here. So either DSA, Digital Slide Archive, QPath, 3D Slicer, or OHIF from the browser, or any other user interface that you want, right? So we could say that MONAI Label has 3 main parts. So the first one and the most important is the server, of course. So we have in the server, we host the annotation apps, the radiology and the pathology app. For this workshop, we'll focus mostly on the radiology app. And in the radiology app, you can see we have different, say, models. So there are 2 interactive models, which is the deep grow and the deep edit, and one which is non-interactive. So say the vanilla model to annotate images, which is, we call it the segmentation model. In the server, we also have of course, the models for the pathology app. So we have Nucleic, deep edit for nuclei segmentation, and the segmentation model for pathology, segmentation for nuclei segmentation, right? Say the model for nuclei segmentation. But those, we are not going to use those for this workshop, right? Okay, so in the server, we also have other features such as the scribbles based algorithm that allows us to create annotations. So it's a sort of a grow from seeds tool that is available in Slicer. So we also have that, like a version of that in the MONAI Label server, just in case the user want to work with that. We also have the active learning strategies and the heuristic planner that works specifically for the radiology app. The second part of MONAI Label is the data store, right? How the MONAI Label server communicate with the studies or the images, right? So specifically for the radiology app, you can use the DICOM web server, where you store the DICOM images, and you connect the MONAI Label server to that DICOM web server. And the other way is the file archive. So you can use MONAI Label server in your local computer, right? Install in the local computer and store the images in a folder. So when you start the server, you specify the folder where the images or the studies are located, and you should be able to use a MONAI Label server plus 3D Slicer or plus OHIF or any other viewer that you want to work with. Okay. So just in case you are not familiar, I guess everyone that is here is familiar with the 3D Slicer, but it's a really nice software for analysis and visualization of medical and biomedical images. It is user-friendly. The really great thing is that the supportive community, so you can post a question and very quickly get the help from the developers. One of the great features of this viewer is that it's really easy to customize, and it's based on Qt and ITK, and you can use the Python wrappers to work with that. So we have created a MONAI Label module that you can use to communicate with the MONAI Label server, and I'm going to briefly describe how that works and how you can use it. So there is another for the radiology app. We have the OHIF viewer. So we also create a user interface in OHIF to communicate with the MONAI Label server. You can start with that and add more features or customize this however you want, right? You want to make more communications or different communication to the MONAI Label server. You can use as a baseline these user interfaces, either the 3D Slicer or the OHIF one. See, one of the beautiful things about the OHIF is that it works on the browser, right? And if you want to use the OHIF, you need to have also a DICOM web server where you store the DICOM images, right? you cannot use the file archive to store the images here. So this is just a print screen on where I show the REST API. For the server, we use Fast API, the library Fast API, which is one of the most common use when you want to create a server. And yeah, so here you have the different API calls that you can make to do inference, to do training, to check the data store. So this is for the server side, and this is how the 3D slicer module and the OHIF communicate with the server, right? So why you should care about MONAI Label, right? So we aim to two personas, right? So one is the researcher and the other one is the clinician. So the researcher is, let's say, one person a researcher wants to create a new annotation method, right? He or she wants to create quick prototypes to show how a deep learning model to annotate images works, and he or she wants to use the sample apps that we provide and start building on top of the ones that we show. So all those applications are based in MONAI, right? So, and MONAI is based in PyTorch. So everyone that knows PyTorch should be able to work on MONAI and then MONAI Label. So that's the research perspective. So we have that platform for the users to work on that. From the clinician perspective, we are basically he or she wants to reduce the time and effort spending on annotating new data sets, right? And for those users, we develop the 3D slicer module and the OHIF module or the OHIF plugin for them to annotate the data sets, right? So we still have a lot of things to do to facilitate that, but that's the ultimate goal. That's the persona that we are also aiming to, right? And of course, for the pathology, I haven't mentioned a lot, but we also have the digital slide archive and the QPath user interfaces that either the pathologist or the researchers on pathology applications, they want to build on top of that, they can also use those applications or those user interfaces to work with. So how to create a MONAI Label app? So there is the two important things to consider here when you want to create a MONAI Label app. So the most important one, I'm talking about, again, the radiology application. So the first thing that you need to define is the number of labels that I want to segment. So say I want to segment the lungs, so right lung, left lung, and the airway. So you need to define the label. You need to put the names to those labels and assign a number, right? So say 1, 2, 3, label 1, label 2, label 3. So that's the first step, and you can modify that in the source code, right? And that's the first thing. So how many labels I'm working with? So say 2, 3, 4, 5. So that's the first thing. The second bit is we need to prepare the data set, right? Are we working with DICOM images? Are we working with NIFTY or NRRD format? So, and how are my images? How many images I have? Can I use the file, the folder? I'm using DICOM Web, where I'm hosting the server, basically, and where I'm putting my data set. So you need to organize the data set accordingly to you need to organize the data set. So how MONAI Label basically manages the data store. I'm going to show you that how you should organize that. For the demo today, we basically skip those two steps. I'm going to show you which label we select and how the data store was organized. So for demo, thanks to AWS, they organize all these things for us. So we just go directly to the slicer. And then the other bits. So select the spatial intensity and the transformation. So this is more for the research perspective. So they want to do a different data augmentation. They want to change how the intensity is modified, or how the images are pre-processed before we train the model or before we do inference, right? The user wants to work on different active learning strategies, right? So they can do that. They want to experience or try a new network architecture. So now we have network architectures that are based on transformers. So say, Andres, instead of using the vanilla UNet or the UNet based on transformer, the UNETAR. I want to use the swing UNETAR, so you can also change that. So that's more for the research bit, right? And an extra, say, thing from the MONAI label application is, Andres, instead of working with clicks, I don't want to interact with the model with using clicks. I want to interact with the model using ROIs or closed curve or any other interaction. So you can also build on top of that, right? On top of the applications that we offer as examples. There is also a tutorial that you can use that is in the GitHub repository on how to basically modify the transformations and everything. If you have any question, please don't hesitate to ask or open a discussion in the GitHub repository. Okay, so if you go to the GitHub repository, you will see this, say, app structure, the organization that we have in the radiology app. Again, this is more for the kind of a researcher that wants to modify the application or they want to know how the application works. So if you go to the GitHub repository, you will see the radiology app, and it's the same for the pathology. It's the same structure. You have a main file where basically we instantiate all the classes for inference and training. So that's the main file. And in the application, you also have a lib folder, library folder, where you have a subfolder that are active learning, configs, infers, trainers, and also transforms. So the active learning and the transforms are empty. So we use those as a space for the users. If they want to build on top of the application, they can put the classes or the transformations there. Say, I want to use a different transformation that is not available in MONAI. I want to create a new one. So you can put that class in the transforms and use it in your application. So we have the configs, infers, and trains. So in the configs is basically where you define the label names. You remember I mentioned in the beginning, if you want to use a MONAI label app for different labels, is there in the configs is where you define the label names, is where you define the network architecture, and is where you define the ROI size. If you want to work on the whole image or batch-based images, you basically define the configuration there. If you don't care about that, you just use the default configuration. So you can use that, right? The only thing is, of course, you need to define the labels. There is no default. They say I want to work on only liver. You need to change that, the liver label. In the infer and trainers is basically where you define the classes for inference and the classes for training. And what is the class for inference? So all the transformations that you apply to the images before you perform inference, and the same for trainer. So the data augmentation that you apply to the images before you start the training or during the training process, right? So that's already set up. If you want to change it and you want to customize it, you want to increase the performance, that is the space for you to do that. This is just an example of how you define the labels, right? This is a dictionary where you define, I want to work with these sort of labels: spleen, right kidney, left kidney, liver. If you don't want to work with all those labels, you just change the names, remove the names, and adjust the numbers accordingly to the labels that you have. So this is just an example. I use the UNet base in transformers, the UNETAR, right? And I use the BTCV dataset that is I don't remember the number of images, but it's like 25 or 20 abdominal CT images where you have segmentation for most of the abdominal organs, like the kidneys, liver, spleen. You have also the stomach and aorta, inferior vena cava. You have plenty of, like 13 or 14 organs. So I use 8 organs to segment on the CT images, and I use as a network the UNETAR, right? So how you organize? So this doesn't work for the workshop because the workshop is already sorted. So the Qing already organized this very nicely. But if you want to work in your local computer, because MONAI Label is not only for the cloud, you can use in your local computer. If you have a basic GPU, it should be enough for you to try a MONAI Label. And this is the case where I have a bunch of images. So you see on the on the left hand side, you see the folder organization. So let's say I want to start. I have images and I already have labels, right? So this is the case. So if I already have labels and I want to train the model, this is the way you organize it. You put the images in a folder and you create a subfolder that is called labels and another subfolder that is called final, all in small letters, and you put the labels inside final. Labels and images should have exactly the same name. So the MONAI label recognizes that which image has their label. If you don't have label, there is no issue. You can use 3D slicer to create the labels. The only thing that you need to do is to put the images inside a folder and start the server with that. Okay. This slide I wanted to just mention that because of the nice feature of Slicer, you can customize your MONAI label module, right? We propose a module. We know it's not the best one, it's not perfect, but let's say you want to customize it, you want to add more features, right? So you create using Qt or the wrapper for, using Qt, you can create your buttons or the interaction that you want to have in your MONAI label module, and then create the connections, how to communicate with the MONAI label server. You make the REST API calls, and then you use MONAI label module as however you want. So one of the examples I show here is the Scribbles algorithm. The Scribbles algorithm is not based on deep learning. It's a classical machine learning tool, but we wanted to show you so you can see how Scribbles can be used in the server and how you can communicate with the server using the MONAI label module, right? Very quickly, what is Scribbles? Again, is similar to the Slicer tools that you have in Slicer, so they grow from seeds. But instead of calling seeds, we call it Scribbles, so you create a data set. You create labels based on the Scribbles. So there are two types of Scribbles. One is the Scribbles only that you use to create labels from scratch, and the other one is the Scribbles that you create to modify the prediction that you get from the deep learning model, right? So this second one is still a work in progress, but the idea is to have both, right? To create labels from scratch or modify the predictions that you get from the server. Regarding the active learning strategies, for the ones that are not familiar with this, is basically a selection system, right? In which a pre-trained algorithm wants to learn from. So let's say you have a pre-trained model, and that pre-trained model basically sorts the unlabeled images from the most difficult one to the less difficult one. So every time that the oracle, the expert, the clinician say, send me next image that I want to annotate it, so the pre-trained model will send the most, from the model perspective, the most uncertain one, the most difficult one, right? In this way, every time that the user fetch an image, it will send the most difficult, annotate the image, and then once it's annotated, it will be part of the training pool. The model will be updated, and the idea is to increase the performance every time that the user provides more labels. So now for the hands-on session, finally, again, so it's important to highlight that because we are using the AWS instance, we already decide which labels we are going to work with. So in this case, will be the right lung, left lung, and the airway, right? The data store is already organized as MONAI label will read it. And I wanted to split this hands-on session in two parts. So one is, let's start saying that we don't have labels. So we only have images and we don't have any pre-trained model. So I have a bunch of images. I want to create labels and then trigger the training process, right? To create the labels, I'm going to use the grow from seeds. Once I create a label, I trigger the training process. We can simulate that we wait for 3 to 5 hours. We are not going to do that. We already have a pre-trained model. We trained it before. But the idea is, you create the labels, show you the pipeline, how you train a model. And then once you have the trained model, you perform inference using the trained model. and then you can modify that label using the tools that you have in Slicer, and then resubmit the label, and then you update the model. So that's the part one. We call it cold start. The part two that Dr. Rudolf will show us is another way of creating labels, which is faster for the lines, and how basically you modify the labels and or modify the predictions. Okay. After that, I have a bunch of frequently asked questions. I don't know if we have the time for that, but just to let you know that we have. Okay, great. So let's go to the.
And Andres, there's two questions here in chat really quickly before you kind of jump over. One was asking, what workflows does MONAI Label support? Is it just segmentation? And then do we support multi-class or two-class classification as well?
Yes, so very good question. So MONAI Label is specifically for segmentation. Okay. We don't do classification. You can use, so once you train the model, when you create a model to segment, you can use MONAI, the main library, to do the classification. So the MONAI core allows you to do segmentation, registration, classification, anything. But MONAI Label is specifically created for segmentation. Okay. Multi-class, yes. So that's the demo that we're going to show. You can do multi-label, right? Multi-class segmentation, not multi-class classification. I don't know if that makes sense.
Yeah. And then there was another question here, and I don't know whether this is for you or maybe for Steve or someone else, is there documentation in the current slicer, how to modify either the current slicer module? I'm going to link the plugin or GitHub repo where it shows the plugin that we're using for MONAI Label. But I guess any general documentation or support for modifying the plugin or anything else.
Okay, I can show you briefly that if once we finish the demo.
Yeah.
Yeah, I can show that it's actually very easy and very interesting. Once in the beginning it's a bit difficult because you need to consider a couple of things, but I'll show you the things that you need to pay attention, and it should be easy to modify the user interface. Okay. So
awesome. Thanks.
If you remind me, please, to do that, because I don't want to forget, because it's interesting.
Yeah, I'll try to remind you. I have it here on our Q&A list, so if we have time after, we can kind of make sure to go into that.
Excellent, very good. So basically, I'll do exactly the same thing that Qing did. So I already log in in upstream, right? So it didn't ask me to change the password because I already did it. So I click on Slicer, start Slicer. Wait for Slicer to start.
Hey, Andres, quick
Yes.
interrupt. Do you think we'll get the email soon with the login? Or are we supposed to get them anytime soon?
Oh,
yeah, this is Qing.
Yes.
Yeah, I'm sending it out right now. You should be getting them in the next couple of minutes.
Okay, great. Let's continue. Yeah, thank you.
Okay. So yeah, I can wait. In the meantime, I can try to answer that question if or is it too advanced, because I don't want to disturb the question of how.
I think you can continue. If people have to drop off, they'll at least get to see. It was just a few people had been asking that if we're going to get the logins anytime soon, or if they missed them. So just continue. I appreciate the way you're doing it. So keep going.
Okay.
And one thing I'll mention too, Andres, is that we have our MONAI Label video series that Andres and I are putting together. So if you do miss any section here, we're hoping to kind of put out individual little small segment videos that'll kind of help walk you through this. And then this video will also be posted on our MONAI YouTube channel. So if you get access later, you want to walk through it, kind of follow along with Andres, you'll be able to do that as well.
Excellent.
Yes,
thank you.
Definitely. Okay, excellent. So once you have the slicer here, so the next step is to know. So yeah, you click here on MONAI Label module. So you have this MONAI Label module here in Slicer. One of the modules, one of the 1,000 modules that you have available in in Slicer. So this is already installed here. Next step is to know the IP address of the server that I want to connect, right? So you go here to the applications that you have available in upstream. So I want to connect to the MONAI Label server that is up and running already, and I copy my IP address. Everyone has one that is different, right? So I copy that and move to my slicer, right? And paste it here, okay? So one is pasted here, you connect to the server, right? So you know how it is connected because the next sample is activated, right? So if you see it's not connected here because the next sample is not activated, so you cannot do anything here, even if I click here, right? So you first need to connect to the server, and once it's connected, you see that next sample is activated. So the first thing I have to do, so thinking in the background, we have the MONAI Label server, and we have the MONAI Label server communicating with the file archive, with a folder where I have my images, right? So once I connect to the server, the first thing I want to do is start annotating images. So remember, the cold start is, okay, so first thing is to get to know the module slicer setting and main button. So let me show you first this. So what we have here, we have the active learning bit, right? So we have the different strategies here. So these two, the random and first, are the vanilla ones. We didn't activate any sophisticated active learning strategy. So we're going to use the random one because the idea for the first part is that we don't have pre-trained models. If we don't have pre-trained models, we cannot use sophisticated active learning strategy, okay? So this is the first step, active learning. The second step is the segment editor, which is basically a copy of one of the modules that you have in Slicer, right? So this is exactly the same thing, this module, right? So we just put it in the MONAI Label module. So to come back, you go previous modules, or again, click here. So you have this tab, segment editor. The auto segmentation is basically, if you have a pre-trained model, you can use that pre-trained model to annotate the volumes that you want to segment. In the first part that I'm going to show you, we think that we don't have, we start thinking that we don't have pre-trained models, right? So we cannot use any automatic segmentation. The last step is the scribbles, right? So you can use scribbles to annotate the volume. Why this is deactivated? Because I don't have any image here. It will be activated once I have that. So this is the basic MONAI Label module. You want to know the hyperparameters of the network, how many epochs, the learning rate, the type of data set that you want to use. When I mean data set, is the class to load the data set and to do the training. So this is more for the researcher persona. So there is an options tab that is deactivated, but you can activate it by going to edit application settings, right? And you go to MONAI Label and you activate the developer mode, right? So once you activate the developer mode, click OK, and you reload the module. And once you reload the module, you see that I have now an options tab here. So connect to the server. And once I have the options tab, you will see that I have many options here, right? So this is more like more buttons to modify how I train the model, right? How, if I want to use multiple GPUs or not, if I want to change the early stopping. So this is more for the researcher persona, right? Just to let you know that this exists and you can modify that in the module. Okay, so that's get to know the slicer module and the MONAI Label buttons and everything. So now segmentation based on growth from seeds. So let's say, yeah, I don't have pre-trained model, I don't have a label. So I want to create a label. So I fetch the next sample, right? Depending on the area that you are, it can be slower, it can be faster. Yeah, but so you get the one CT volume, which is the case that we are working now, CT images. So you see that Scribbles is activated now. You can use Scribbles or you can use the grow from seeds. How you can use the grow from seeds? Basically, I want to segment the, again, I define, before I start the server, I define the labels that I want to segment. So I want to segment the right lung, the left lung, and the airway. So I'm not an expert on this, but I'll try to segment those organs. So the first thing to do is to create a label that is background as well. This is to use the growth from seeds, right? Let's say background color, double click, and I change the color to, yeah, background, black. Okay. So I'm going to provide seeds to create my label. So for the right lung, right? This is the right lung, right? So I provide seeds for this. This view, seeds for this view, right? And then if you press the key Shift and you keep it, you can move the cursor and you basically move to all the views to be in the same position. So I can provide seeds in the same place, right? You can only click or click and move the cursor and provide seeds for that. And the same, you can do the same for the left lung. Okay. So this is the left one. Again, I press the Shift key to move to the left. Now this is the left lung. Right. And now, I'll create labels for the airways. Sorry, create labels. Create the seats for the airway. Because this is quite big, I'll reduce the size of the brush. Okay. You say this is the airway. Control, and if you scroll, you can do zoom, right? To create more labels. This is the airway. I'm not an expert on this. Dr. Rudolf will show us how he create the labels. And once you provide, basic seeds, so I want to see how this is performing. I also need to provide the background. So what is the background? Of course, it's very important. So background is basically everything that is not right lung, left lung, and airways. So let me use this size of brush. So this is background. This is all background. Right. This is the heart is also background for us. So now that I provide seeds, let's see how that goes. So if I go here and click grow from seeds, right? And initialize, it will take a bit, depending how big is the image and how far is the server, right? Depending on the area that the server is located. In the meantime, while we're waiting, I don't know if there are questions. So here we are creating the label, right? So we are not using here MONAI label yet. We're using the MONAI label module, right? And we are using the grow from seeds functionality in Slicer to create the label. So we're basically creating one label that we're going to use to train our MONAI label app, okay? So that's the first step, the first bit. Is there any question that I can answer in the meantime?
The only question. Yeah, I'll say there's one question with people having an issue connecting when they actually use the MONAI label extension and connecting to their server. I would say make sure that you are copying and pasting it correctly, and there is the HTTP:// your IP address, similar to what's showing you in that MONAI label command console that you're using to get your IP address. If you double check it, make sure there's no extra spaces, nothing weird in there. Ping in chat and we can Qing or Gong or someone else on the AWS team. I don't know if there's a way to check that maybe the EC2 instance is having some issues on their end on one of the specific users. But definitely keep letting people know in chat, and we'll hopefully get you some help soon.
Yes, definitely. This is Qing. So most of the servers are up and running. We do have a number of servers that are still downloading the large data set. So when you couldn't connect to the MONAI Label server, please, in the chat, please let us know your email address so we can check which server is assigned to you and make sure it's running. Or if it's still starting up, we will also be able to find another server, like unused server, and assign to you to get you started.
Great, thanks, Qing. Yeah, so definitely keep, if you have an error, try again another minute or two, give it a few minutes, try again. And yeah, just keep pinging back if you need help.
Right. So Qing, just referring back to your presentation earlier. So basically what we've done is preloaded all these data sets, right? So that everything will be ready to go, but that's being shifted from a bucket into a upstream instance or into the SageMaker instance. Is that what's going on?
Yeah, we are pre-downloading the long data set that Andreas is showing right now from the S3 bucket into the MONAI Label server. So we're doing all the setup ahead of time. So when you log in, you can just start using the data set without downloading.
Okay, great. And that's since there's a unique one for every person in the workshop. It's all happening in parallel.
Yes,
Great.
yes, we're downloading this multiple times, one per each user.
Perfect.
Okay, so we just got the segmentation, the first draft. So you see the model, the grow from seeds tool gave us a round area, so we can still fine tune that. This is part of the background, so you can still say no, this is part of the background as well, right? To modify the segmentation that you got from the grow from seed tool. So I'll provide a couple of more seeds and go to the next step. So you see what's happening. Yeah, so it works. It seems to work well. Let me see. So once you feel that this is good, you can go to again grow from seeds and apply. Okay. So once you apply that, you can see. You click here, show 3D. You can see the segmentation that you got for the right lung, left lung, and airways, right? So it's not perfect, right? You see, it's a bit. There is an area that it seems is not part of the lung. I'm not an expert. I'm not a clinician, but let's say this is good, right? So we now are here. So we get to know this slicer module, get a segmentation based on the growth from seeds, and then start the training process. So now that we have one label created from slicer, we can train a model, right? For that, we go to the active learning bit, and you see that this button is now activated. So we now can send the label that we create in slicer to the server. So we submit the label. Once we submit the label, so this is submitting, is sending it to the server, right? So you will see here that is 1%. What does it mean? Basically, if you place the cursor on top of that tab, it will show you that you have one label for one volume out of the 63 volumes that you have in the file archive in the studies. Okay. So now with one volume, you can trigger the training process, right? So you can train the model, so trigger the train. So while the model is training, right? So you will see here is the training started. You can continue annotating the another volume, right? While the model is training in the background. So I just wanted to show you how the training is happening. So you see here and go to the terminal and see the logs. And to see the logs, you just copy exactly the same instructions that Qing did in the beginning. So we copy this. I want to see the logs of the server, and you will see that let's expand it a bit, and you see that the model started to train, right? Total records for training 1. So I'm using one volume to train my model. So in the beginning, of course, I'm using only one label to train my model. In the beginning, the model will not perform well, right? So we need 5 or 6, depending on how difficult are the organs to segment. It will take more time to train, or it will need more time to train, or it will need more labels to get a decent label, right? Once the model is trained. So you should be able, and by the way, these are the hyperparameters that we have by default to do the training. So you can change that in the options, right? You can change that, these hyperparameters here in the options. Right. Those are the arguments that I use to trigger the training process. So maximum number of epochs, 50. So I'm going to train my model for 50 epochs, right? Validation split. So because I only have one image, if I have more, it will use 20% of the training sample to do the validation, to check how the model is working, right? Yeah, basically. So this is the part one. I don't know if there is another question here, but basically this is the bit that I wanted to show, the part one. Of course, so the section 4 of the part one, which is simulate that we wait for 5 hours of training, right? And see how the inference of the model after, I provided 3, 4, 5 labels and the model was training, how the model works. So once I have my model trained, I can fetch the next sample. So in active learning, fetch the next sample. Let's see if the training happened here. Oh yes, it was training. I didn't see the logs. Yeah, so you see epoch 48, right? 50 epochs. So it trains 50 epochs like very quickly in 5 minutes. Right? If you provide more labels, it will take more time. But yeah, just that. Now I fetch an example. And instead of using the grow from seeds, I have a pre-trained model after training for 5 hours, 3 hours, depending on how many organs, how many segments you want to do. It will take more time or less time. But let's say I'm working on this and I have a pre-trained model. So now I can use the automatic segmentation. So I have my model, which is, I call it segmentation. And now I can click here to run inference on this image. So what this module will do is use that volume, the lang 0.75, to perform inference using my pre-trained model and send me the predictions of the model, right? So this will take a bit, depending on how far is the server. If you're working on your local computer, it's faster because both server and the slicer is in the computer. But because this server might be in the West Coast, in the US or in Ireland, it'll take a bit. Okay. Let's see what is happening here. Yeah, so you see, I use the, what is this? So I use this infer request. I sent a request, right, to segment the lang 0.75. So once I send the order, the system will do basically apply the pre-transforms. So it load the image, do the spacing that I define, scale the intensity, do the infer, and then do a post-transform. Basically, return the image to the original space and original size if I change it, and then send the prediction to the server, to the user interface, to the slicer module. So now I got the segmentation, right, from my model, the model that I have. You see, it's still not perfect, right? But at least I have the segmentation faster, and I can modify this prediction by using the tools to say, this is a mistake. This is not part of the left line. So I can still go to the segment editor, and let's say I want to remove that. I use scissors to remove this bit. This is not part of the left line. Right? So I remove that. also this bit. This is not part of the left line. So you fine tune the label, the prediction that you got from the PTM model, and once you are done, so let's say, yeah, this bit is also this is not part of the right lung. So it's right lung and remove this bit. This will only remove the right lung. It will not remove the yellow, the left lung. Okay, so you see, I remove almost half of the of the lung, so I can return to the yes. There is not the control. Yeah, you can undo this in the local version of Slicer, but if you make a mistake here, you can again perform automatic inference and you will return to the original segment. So that's part one. I don't know if Dr. Rudolf is available, so he can show us the part two on using lung CT analyzer module and how he can create the labels.
Yes, hello, can you hear me?
Yes, we can hear you.
Very good. Yes, thank you very much for having me. It's a very interesting topic, and I'm going to share my screen. Can you see my screen?
Yes, we see it.
Okay. So, yeah, maybe you need 5 minutes coffee break. This was quite a lot of information, but what I'm telling you now is in the direction which is quite similar. My name is Rudolf Bumm. I'm a senior consultant surgeon at Kantonsspital Graubünden in Chur, Switzerland, and I was getting involved into this by programming the lung CT analyzer, which is a program which can make lung segmentations and analyze the lung areas according to thresholds. This was kind of a spin-off of the COVID-19 pandemic. And when I wanted to come to this workshop, I've already done the January one, but I didn't want to come as unprepared again. So my plan was to set up a MONAI Label server on my own computer, which is a moderate to high-end gaming PC. I wanted to load some apps and data sets, lung data sets, and I wanted to use the lung CT segmenter for creation of detailed lung labels for right lung, left lung, and airways. We wanted to do the training process and evaluate whether it's working right in this context. So Andres and I met about 1 week ago, and I was doing 2 weeks more of preparations. I found out that you need quite a strong PC for that. You need a Nvidia GPU with at least 16 or 24 gigabytes of RAM. MONAI Label also runs in CPU mode, but it will take a long time for do any segmentations. So we recommend to have this kind of computer available for that if you want to do it locally, or go to AWS and rent a server instance with a good CPU. You need to install Python 3.9. You need to install at least 3D Slicer 5.0 and to have these extensions available. So we have this data set, which is already pre-installed on your server right now. Yeah, you have to do some things on your local computer, which I have posted in the chat. There's a Google Doc which has all this information. I can show it later shortly. So there are some steps to follow, but starting the MONAI Label server is rather simple. You only need to have 2 commands from the command line, and then you have it up and running on your own server. and you can access all the necessary functions from the web browser on your own computer if you have this URL available and paste it into the browser. Yeah, we enabled developer mode in MONAI Label, labeled 2 data sets initially with a lung CT segmenter. I'm showing you this in 2 minutes. We trained 50 epochs, 2 iterations. This took about 5 minutes on my graphics card. And I got this result. And then I called Andres and said, hey, Andres, I got it all up and running, but it doesn't really show something good. So he said, okay, you just need to label 5 more data sets and do a bit more training. So we trained the server for 1,000 epochs and 5 iterations. That took us about 1 hour. And then we already got a better result. This is the deep edit model, which already was able to divide right lung from left lung and the airway. And then I did 17 more data sets. That's what you have on your servers right now. And we trained another 1,000 epochs and 22 iterations. It took 6 hours. And then we got a much better result, but still there were some errors. For example, here, a hole in the lung was something missing. But we just did what Andres just told us. We corrected this error. And then we have, after auto segmentation, we have had a very good result in my point of view. This only took 11 seconds on my server. So before I go to finish my speech, I just want to show you the view to my local server where I do all this and show you how you can start the server. You just start the PowerShell. This is, you need only to enter 1 command and a second command, and then locally the server will be started running in the background. And then you can start Slicer 5.1 and you go to MONAI Label and connect to the server. And then you have all the data sets available in the background. And just to show you what the lung segmenter can do is we want to segment this lung, right lung and left lung, and the airway. So we go to airway segmentation and say start. Then we just place a few samples on the right lung and on the left lung, and again on the right lung and the left lung, and 1 in the airways. And then we have got pre-segmentation here. And if you press the apply button, you need to wait for approximately 20 or 30 seconds to have this kind of segmentation in 3D Slicer, which you can then feed into the MONAI Label system. And that was the process that we have done for this workshop, and which you can also do now on your local server. If you want to go and use the lung CT segmenter, you just search for it in the module drop-down field. I can show you this in a minute. Now, this is the result of the CT segmenter, and you see that we have got very nice airways. This would be sufficient for our surgical planning. We have every sub-segment available of the right and left lung. And then we would go back to MONAI Label, and then we would click Submit Label and feed this into the server. And again, if I want to demonstrate the auto-trained model, I load the next label from the server, next sample, and I just click on run. And it will take about 11 seconds or 12 seconds to have the result coming in from the MONAI label server. And this is an excellent result. And I must say I was skeptical before I started this, but after setting all this up and training, I think this is just amazing. What can be achieved in 11 seconds in 3D slicer with artificial intelligence. So now let me try to come back to you and finish my talk. Okay, I can close this. Well, what would be the next step for me? And maybe also for you, for your plans. Of course, it would be nice to have MONAI label in higher resolutions. You saw these Minecraft segmentations in the beginning, and it's of course very good to have a high resolution, but this would require better GPUs, and this is something that one would maybe have to rent in a cloud service. My next step will be segmentation of lung lobes and maybe detection of lung nodules and tumors. And well, maybe we can also train models for analyzing COVID patients or interstitial lung disease. Yeah, I want to say a big thank you to, of course, Andres, who is doing this workshop very well, to Steve, who organized it, to Qing, who did a great job to set this all up, and Steve, and also to Anders Lasso, who helped me program the segmenter. Thank you.
Well, thank you very much, Dr. Rudolf. This is very nice. I don't know if there are questions for Dr. Rudolf or comments, or I have a couple of things that I want to do. So one is how to modify the MONAI label module, and also go to the different buttons, more buttons we have in Slicer, and also the frequently asked questions. But just wanted to check Steve or Michael if
no, I think that sounds like a good plan, and people have been getting connected to their servers. I don't know if there are any other questions from people. I wanted to just comment that, like Rudolf, I might have been a little skeptical at some point in my history, but I think what's amazing about what we just saw is we started with a kind of a block diagram that indicated there'd be a cloud server and an AI and a clinician and some data. And then we actually just saw that actually happen, not exactly in real time, but we got the result of the last few weeks of that actually happening, because I can vouch that Rudolf is a real clinician doing real work. And it's great to see that really come full circle. So yeah,
I just a brief thank you to Rudolf and to Andres and everybody else who led us to the point that Rudolf could do this. I'm late for my next meeting because I wanted to stay here to see you do this, Rudolf. This is amazing. I think in every workshop we do, if we could have a surgeon, a clinician like Rudolf come in and actually show us what they can do, that's really where the rubber meets the road type.
I think that's I agree. Rudolf is maybe one of a kind, but he could be the thought leader that brings the others with him, because not everyone would be able to do all the things that he was able to do. But now that it's all sort of laid out, yeah, I think it will be great to get some other surgeons involved.
Yes,
Rudolf. Yeah, and there's so many topics that you could tackle with this kind of MONAI label server setting that, well, you have to think about it, and maybe we can use the project week And I'll comment on some of these projects that I see that want to use MONAI label and help maybe to get that started. It's not very complicated, I must say. The hardest thing was to set the environment up. But if you get this done, then that's quite easy.
And Rudolf, in Project Week on Thursday in Project Week, we have a breakout session that is dedicated to learnings from this workshop. Perhaps you can lead that with your experience on the demo, because there's another 50 to 100 people who couldn't show up here but would really want to know how this went.
Yeah, absolutely.
Yeah,
I can do that.
Okay, great. Thank you very much. Now we can go back to the rest of the program.
Okay, so excellent. Thank you, Rudolf. Thank you. Let me share the screen again, and you see the what is this one? You guys see my screen, right?
Yeah.
Yeah. So once you download Slicer, so I'll start from the very beginning. So you download the Slicer and you open the Slicer. This will be the first window that you see, the first welcome module. So we don't have MONAI label here installed. So the first thing to do is to install the MONAI label extension, MONAI label module. So you go here to view extensions manager. So I'm now on my local computer, right? This is yeah, my personal workstation. Then you go, so you install extensions and you go to active learning and you will see MONAI label extension. Right? So you install the MONAI label extension, MONAI label module, and you click here on restart Slicer. Okay, we will ask you to restart Slicer. So yeah, you want to restart? Yes. So when you restart Slicer, you should be able to see the MONAI label module in here. So if you don't see here, you can search here in modules, MONAI label, right? You will see here, or you can also click here on welcome to Slicer and go to active learning. If I find it, what is active learning? Yeah, active learning here. So sometimes you will see it here in the end, but it's here now. So you see MONAI label there. So there are three ways. So you're either here, searching modules, or in this list of modules, right? So let's go to the MONAI label module. I have this MONAI label module. In the AWS configuration, I don't know if you remember, we have different buttons. Let's not remember. So you see these buttons: reload, and text. You see that I don't have that in my installation, right? I don't have it here. So to make these buttons to appear, you go to here to edit, application settings, and you go to the developer mode. In developer mode, right? Developer mode of this list, you click here and activate the developer mode, right? And again, it will ask you to restart Slicer. Okay, yes, and I restart Slicer. And now you will see these buttons that you see in the AWS configuration. You go to MONAI label, you see those buttons, right? So now in the same place. So how I modify the module? So you can click here in edit user interface. If I click here, you will see a window. It will show. There will be a window that is this one, and this is basically Qt, right? Or Qt. I don't know how to pronounce this. So basically, you have all these buttons in the user interface. So let's say, Andres, the module, the MONAI label module is a bit complicated for my for the clinicians that I'm working with. So I'll try to simplify it. The scribbles, I don't need that, so I remove it. This, I don't know what is this. I just remove it. The segment editor is the same that we have in Slicer. I don't need it here in the MONAI label module. You can remove that as well. So this is for the user interface, right? So this is the buttons that you have in the user interface, but those buttons have a function. So it's basically, you can think like this is the buttons in the dashboard, and there in the back end there is, or in below there are cables that connect the buttons with the functions. So say, for instance, next sample has a function that is do a call, a REST API call to the MONAI Label server to fetch a sample, to send the sample to the module, and then visualize it in Slicer, right? So this is the user interface. Let me Control Z, right? I don't want to modify that. So once you modify that, if you go to the, let me see if I can show you. You go to the main repository. Come on. Let me show you here directly because I have the MONAI Label GitHub repository. So this is more for the, this is not for the clinician, this is more for the researcher, how to modify that, right? That was the question. So I download the GitHub repository for MONAI Label, and I have here the plugins. In plugins, I have Slicer, all the plugins that I have, DSA, OHIF, QPath, Slicer. In Slicer, I go to the MONAI Label, and in MONAI Label resources, I have the user interface. So this MONAILabel.ui is basically the configuration that I have for this in text, because it shows here now very nicely in buttons, but it should be represented in text, or it's represented in text. So you have all the connections, all the buttons here, right? Not the connection, the buttons. And now the connections is more Python. So how you modify the connections, the functionality of the buttons. So you go to the, again, to the same MONAI Label, and you will see the MONAILabel.py. The MONAILabel.py is, let me open it with the PyCharm, which is better. I have it here, plugins, Slicer, MONAI Label. So here I have a bunch of classes and things that basically describe the functionality of the buttons that I have, right? In the class MONAI Label logic is basically, I have the method that makes the call to the server, right? I don't want to extend more of that, but it's basically the two things that you need to pay attention, right? So the user interface and the .py file where you have the functions of those buttons, basically, right? So the different classes that you need to inherit from to create the MONAI Label module or to modify it based on this one. So that's the bit that I wanted to show. And the other bit, just to wrap up the presentation, the workshop, is the frequently asked questions. I just wanted to go through them and finalize this bit. So we have, so how I should organize my data set to train the model, right? So there are a bunch of questions. So the first thing is a single modality. So I'm working with CT only, or I'm working with MR that is multi-parametric. So T2, T1, so that's the first thing. It's a single, how many labels I'm segmenting from those images. And I need to check if I already have labels, are the labels consistently segmented? So those are the questions that I need to ask before I start my MONAI Label server. So paying attention to the data set that I have is very, very important. Which file formats MONAI Label support? So we have basically support for all the radiology applications, so any NIFTY, compressed NIFTY, DICOM, NRRD, yeah, the most popular ones. Where my pre-trained model is located. So there is a folder that is called model. So if I go to my application here in the MONAI Label, I have my sample apps, radiology. When I download it, I have a folder that is model. In model, I have the pre-trained models that I'm working with. Right? If you don't have pre-trained model, you can create it. So that's one of the advantages of MONAI Label. You can quickly create a pre-trained model. More questions. So what is this? Yeah, here. So can I use a pre-trained model? Can I do transfer learning? So yes, you can do that. But the first thing is, of course, the pre-trained model that you have is for how many labels, right? Did you use the same architecture that is in the sample app, in the radiology app? If it is not, you need to change the same architecture, right? The other question is, did you use the same transformations to do the data augmentation? Right? if all those questions are yes, you basically just place the pre-trained model with one of these names, depending on the model that you're using, one of these names, pre-train underscore deep edit dynamic init. Dynamic init is one of the network architectures that we have. And then you should be able to use it. If they are for the same number of labels, if they use the same transforms, if they use the same network architecture, right? So doing transfer learning, doing using the pre-trained model is a work for the researcher more than the clinician, right? So all these things are more for the researcher to work on that. Okay, so next question is so label encoding. So basically you put a name to the labels, put a number to the segments. If you already have labels, you should pay attention to the numbers associated to those labels, right? When to use scribbles? When I want to create a label, right? It's basically the same functionality as grow from seeds, just that. Can I combine the power of MONAI label with the manual annotation tools? Of course, you can do that. You can get the prediction from the model and use the scissor to modify the prediction, or even use the land city analyzer, the functionality that Dr. Rudolf showed to us. There's another question about the configuration. When you start the server, there are different arguments for the configuration file. So basically, it allows you to define the network architecture to use a pre-trained model or not. So you say, I don't want to use a pre-trained model that is available in the sample apps. To define the target spacing, the spatial size, you want to use a different active learning strategies, right? Which one do you want to use, the epistemic uncertainty strategy or the TTA, test augmentation? Again, this is more for the research perspective. Let's say I want to try MONAI label. Once I start the MONAI label, so again, maybe one of the most difficult bits is to set up the environment. We are addressing that. The idea is to create a standalone version where we don't need to deal with the terminal. This is more for the clinician. But the current status is we need to deal with the terminal. We need to start the server. We need to install the create the environment. If you install the environment, you're still facing issues. So one thing is to check the logs, and ask the question in the discussion section in the repository, or create an issue, right? Another question is, does MONAI label support multiple users? Yes, it supports multiple users, but it doesn't support multiple annotations for the same image. This is currently under development. We are working on that. We are trying to prioritize depending on the ask that we got from the users. And the way we check that is basically on the GitHub repository. What's the minimum GPU memory? So it depends. If you are using the deep edit or you're using the segmentation model. So the deep edit uses the whole image, so it needs more GPU. The deep edit has advantages, which is an interactive model. The segmentation is just the basic one, but you can try the segmentation model from a GPU of 4 gigabytes. Of course, it's not the best one. The performance will not the best one, but at least you can get a sense of how MONAI label works. Last question is, does MONAI label work on the CPU? Yes, you can use MONAI label with a CPU, but of course the speed for training and inference will drastically be reduced. What is the smart edit or how does it work? So it's more for the interactive models like deep grow and deep edit. We didn't have the time to go to those models, but hopefully we get a sense for that in the hackathon. And that's it. I don't want to spend more time. I know that it's already the time. Thank you for your time.
Andres, we have one quick question that came in that I wanted to answer before we kind of send people away. So Andres had asked whether once someone has trained a model and wants to make it available for everyone else, what's the recommended way to do that? And so I wanted to mention a little bit about our effort at our upcoming sort of MONAI bundle / model zoo. I'll go ahead and share my screen really quickly, but I'm mentioning this, but I want to make sure that people know that we're kind of in the middle of figuring out what it exactly looks like to do this. So kind of a sneak peek at what we're working on here in the near future is if you go to our Project-MONAI repo, you'll see this model zoo public repo here. And you'll see that there are currently a few models already in here that are available. And we're creating a submission process. So if you scroll down, you'll see that there's a contribution guideline here for submitting things to the MONAI model zoo. We're going to be working on a separate website for it, ways for you to integrate your models into here and submit them, and allowing people to use those. And if you're using MONAI, and a nice place to be able to go to and contribute your models for other people to use as a basis or to use on their own. One thing I want to mention is that it is part of the MONAI bundle spec is what's required for doing that. So to prepare a MONAI model into a bundle, there are some things that you need to keep in mind. And so on our MONAI core documentation, there are things about bundles. What does it look like? What are the structures? What are all the information that are required in a bundle? And we're trying to use this as a standardization method that we can use throughout all of MONAI and hopefully throughout the industry, where people can use this format and easily allow you to take a model like the Andres showed and that you trained and take it over to deployment. So maybe you skip that MONAI core. Maybe you don't need to train any additional your model any more after you're done doing your annotation within MONAI Label and you're ready to deploy. We're trying to make it easy for you to take that and go over to your deployment platform and deploy it over there, or whatever you want to do with it afterward. So I wanted to mention briefly that. And then the other thing I wanted to mention as well is that if you're doing things like modifying the slicer plugin or creating your own slicer plugin where you want to contribute back and it is around MONAI and you're using it, you can contribute back and open up a discussion within the GitHub repo. So in this case, I'm showing here the MONAI Label plugin directory specifically for slicer. And I wanted to call out the MONAI Label reviewer folder here. So that MONAI Label reviewer folder is a contribution from University Berlin Charity. And they contributed this MONAI Label reviewer here and created their own sort of proposal and issue that they were having and how they wanted to address it using MONAI Label. So this was having annotators, data sets, and reviewers, and having a UI they were able to kind of integrate into Slicer to kind of do a lot of these things of letting people annotate it, getting multiple people to annotate things, and they contributed back this into the MONAI Label repo. So if you have something that you're working on that's not a model, but you're working on an extension, modifying the extension, you want to help contribute directly to the extension and maybe it needs something, feel free to open up a discussion and let us know what you're thinking, and we can work with you to try to integrate that and get any of your work you're doing into the project itself and highlight any of the work that you're doing as part of your research.
Just last comment. Another way
Yeah.
to make the train model available is to connect that to a server that is somehow somewhere available. So once you connect to the server, we can disable the training options or all the options that you can use it as an inference mode, right? That's another option. You say you install MONAI Label server. Once you connect to that server particularly, you can do only inference, right? And you can go through the list of pre-trained models, and that's an option as well. Yeah, just want to do that. Thank you everyone for your time and for participation. I don't know if there is another question. I think we can wrap up.
Yeah, I think we're good for now. So yeah, thank you everyone for joining. And again, if you want to contribute to MONAI, you want to get involved, check out monai.io, check out the GitHub repo. We have a Slack channel as well where you can go there, talk to developers. Andres and I are on there. Again, if you have any questions after the event, feel free to ping us. However you want to get involved with Project MONAI. And Steve, you want to...
Thank you guys so much for this, and especially Rudolf and Andres, because I know, and Qing especially, put in a lot of extra effort to make this all come off so well, and it's much appreciated. One thing I promised the AWS people is to beg everyone to fill out the survey that's going to come in your email. I know it's easy to ignore those, but apparently these people's jobs depend on getting this survey filled out. So, let's do what we can to thank them for all the hard work that they did. And yeah. Everybody, I'm really excited for Project Week next week and digging into more details. I think everybody, came away with this impressed and excited. So hopefully we'll be able to put it to good use, like Rudolf says, in many different areas. So thanks again, everybody.